My guest today is Jacob Salassi, who brings over 10 years of experience in software engineering and cybersecurity to the table. Until 4 months ago, Jacob was a security architect at Snowflake, where he ensured every developer was wildly successful in owning security. Since then, he's been diving into something new and exciting, working on a stealth startup. Before Snowflake, Jacob was busy bootstrapping application security programs in healthcare and engineering secure distributed systems for a hybrid cloud security platform. He's passionate about creating a development security experience that not only measurably reduces risk, but also earns the love of engineers. In his own words, Jacob solves problems. Thanks so much for being on the show with us today, Jacob. It's a real honor to have you.
Hey, thanks for having me, Chris. I appreciate it.
So how did you first get involved in computing, and how did that turn into a career in cybersecurity?
I had maybe a non-traditional entry when I first got into computing, I guess at age 10 or maybe earlier. And then spent a lot of time on IRC, and then rip my early life. No, so yeah, I kind of grew up just on the internet,
Right.
And then I wasn't okay. So, anyways, I didn't attend college for it, but I was always on the internet, and I got into the local scene, I think called the hacking scene in DFW, which I don't know how familiar you are with that area, but at the time, a pretty robust scene, a big 2600 meet, DC 214 meets, and just lots of cool people. So I got involved in that and was sort of pursuing various careers in IT because that was sort of what I was decent at. I was doing desktop support and finally landed a gig in network engineering. And I guess I'll kind of pick it up there because that's where the convergence started. Was looking at PCAPs and interesting stuff in PCAPs, and then sort of thinking about binary exploitation and other things. I found myself at company called Citrix, who had acquired a company called Netscaler, which was like a high-performance load balancer based on FreeBSD. And so the really cool thing I got to do as a network engineer there was look at core dumps and PCAPs from the most interesting networks in the world and the most interesting customers in the world. And so I felt like, wow, this is pretty interesting. And it kind of moved my skills. It helped me sort of apply the skills in binary exploitation. Not that I'm exploiting core dumps, but hey, I can use GDB pretty well, and I understand memory exploration and these kinds of things. And as part of my hobbies, a good friend of mine who was a mechanical engineer got into robotics competition. And so we started to learn C to write, to program Arduinos. And so then I kind of moved it up a little bit. And throughout my career at Citrix as a network engineer, I would often interact with software engineers. And I kind of had this that's kind of like doctors. You think they're magical, but they're really just people who went to school, right? And so I had this perception that software engineering was magical or something. And I had a couple of conversations that sort of assured me that was not the case. And so, I just kind of persisted. I won't dwell too much on this, but Citrix was a great opportunity. I was there for 10 years. So I sort of, wrote a lot of code and showed it to some managers that I had great relationships with, and landed on a development team that was focused on supporting the product. And then I was able to pivot one more time, actually two more times, to a maintenance team that focused on maintaining the product. So first writing the tools that supported it, but then in the R&D org, which was something important and why I came out to Silicon Valley. Anyway, so I finished that career basically becoming a software engineer who had been tinkering in security, maybe more than tinkering, but I had an opportunity with a good friend of mine at a company called Collective Health. And kind of the short story there is we both kind of said, hey, maybe AppSec could benefit from a developer perspective, and hey, do you want to try this out here? So I was like, sure. I've been wanting to make the next move and get into security, but not at a low level. So it's a pretty unique opportunity, really, that a friend of mine took a big bet on me. Mm-hmm. And I'm a pretty studious person. Being an autodidact is kind of what I do. Anyway, so sort of did all the homework, kind of meta-analysis of what the AppSec space was maybe 8 years ago, something like that, and sort of tried everything that I saw. Startups are startups, and so that journey was about 2 years, and I learned a lot of interesting things. And then I found my way into Snowflake just through a job placement. Mm-hmm. And that is where I started, as you mentioned, as a security architect. I spent 5 years at Snowflake, kind of starting as building the AppSec program and architect, being the architect for the major features, and then scaling that to a team of, I think it was 52 when I left, global team. So I left, and ultimately becoming a director of product security. And we had a portfolio of things underneath us. So it was sort of a bizarre and exponential journey, especially at Snowflake. Things really ramped up like a hockey stick. But yeah, I sort of found my way in there, and mostly I took, going back to what you said, I really like to solve problems. That's what I focused on. And network engineering brought me to interesting problems. Security brought me to more interesting problems. And I just tried to work hard, and it played how it played.
Very cool. And you've always been on that like startup journey. What was it that inspired you to like go to Silicon Valley and chase after the thing?
Well, what I realized, it was actually the software engineering part of it first, because like I grew up in Texas and was doing this in Texas, and like Texas software engineering jobs, maybe now it's a different story, but were much more enterprise, and like that's not getting me excited.
Yeah.
So I wanted to get here, and I wanted to become a credible developer because I wasn't. I didn't go to school. I didn't have a CS degree. So it was about the proximity, and it was about the ability to get that job. Citrix would only let me do R&D in California at that time. So that's kind of why I wound up here. But as a byproduct of that, and something that I think is unique about maybe security leadership, I don't know if that's too high up, but security is always evaluating products. And depending on which company you're at, many of those products are startups, which means you're meeting lots of people and you're involved in maybe lots of design partnerships. And you sort of start to see the spectrum of things which can be done and how they get funded and how people have approached it. And that sort of raised my conviction. Like I guess I feel like I had a career that was like, bet on Jacob, you know what I mean? And I kept sort of succeeding, and I wanted to bet again on myself and think like, if all these other people are doing it, the only difference between you and them is that you are not. And so that was kind of one of the main things. There's some other components and like folks I like to work with who I think have relevant experience to make it credible. You can dream big, but you have to figure out how to make that happen.
Yeah.
So the stars aligned toward the end of my career at Snowflake with two other good friends of mine, one from Snowflake, and another from outside of Snowflake who's been a founder before. And we got together and decided like, okay, this is the time. We had actually been talking about it since 6 years back when we worked together at Collective Health. But you know how things are, it just worked out the way it worked. So
yeah. Oh, that's awesome. Yeah. And it's, I can see how not wanting to end up in software engineering in a place like Texas where, it's probably a good career, but not super exciting. Whereas in Silicon Valley, it's like where the new ideas are coming up and all that opportunity exists.
Exactly.
I know you probably can't talk about what you guys are doing at all, but you've been sort of heads down on the new startup for the last 4 months. What's that been like? How are you guys feeling about it?
Yeah. So, it's funny, when I left Snowflake, I spent a long time reflecting on like what's important to me. And so a lot of things are important to me, family and all those things that you would expect. But one of them is like building stuff with my friends. I wanted to have a good framing for how I thought about what I was doing, what my motivations were. That way I would be able to say no to things that sort of didn't align with those. So basically it was, build cool things with my friends. Like that's a good principle.
Awesome.
That I had. And we felt like, of course, if you apply some discipline there, anyway. So that was kind of the first thing. And then we kind of gone through various iterations. What I'll say is this, is you talk to investors, you present them ideas, and those are opportunities to learn.
Yeah.
And those are opportunities to learn perceived weaknesses, whether they're real or not is something else for you to discover. But being able to learn the vulnerabilities in your business and have a lot of those conversations, and then kind of think about how many of these can we mitigate? So I guess the thing is if I've been in like the knowledge acquisition game and like exciting knowledge acquisition, because I don't just acquire it for fun, you know what I mean? Like it kind of has to be on a path. I feel like the thing I've really learned, and maybe it's very self-evident, is like you need to acquire the knowledge of entrepreneurship and like what it is, like what makes a business. You can ask a lot of questions and understand problems, but that has to convert into a business plan that generates returns. And you need to think about whether or not an investor is relevant to that. Like, do you even need to take this kind of money at this time? And I feel like really just trying to, I don't want to say I see other people being swept up in that. All I can say is I don't want to be swept up in that, because what I'll say is, God bless all these VCs. They will reach out to you, and there's lots of VCs who would love to talk about whatever idea you have. And I think it's really important to be able to go in there. Feels good when people are after your attention and things like that. So you really got to check yourself and think like, okay, this is business. What do I have to bring here, and how do I make the best deal for both of us, and those kinds of things. So I think the journey has been a lot about that. Like, hey, let's think about that. How do we intentionally move through that rather than sort of rudderlessly flow through that?
Yeah, I think especially for a lot of first-time founders, they feel like getting that first round of funding means success, but it's actually, that's a tool to get you to the next spot, and ultimately you don't want to sell all the company. You want to try and keep as much as you can. Yeah. Right.
And I think it's just important to be aware of like everyone has incentives and you know what I mean?
Yeah.
you have to be able to think and see clearly.
Yeah, 100%. Okay, so I'd love to talk about product security today, but one thing I was just curious about, which I suspect is related to it, as it was one of your job titles, what is regulatory expansion?
Oh, yeah. Okay. So, I mean, one of the great things about Snowflake, actually the best thing about Snowflake the entire time, was I just got paid to work on hard, difficult, exotic stuff that other people weren't working on. Like maybe not quite as much as a Google or an Amazon, but so we had this massive appetite for, I won't give you like the whole spiel about how the Snowflake org worked, but I was very close to the compliance org and very close to the product org. I reported in the product engineering org. And so part of our motion as a business was to acquire certifications that would allow us to acquire more sensitive data, eventually top secret and classified data. Of course, everybody wants to do that. That is in a cloud data platform space, especially because you want to be able to approach the public sector and get, great government contracts and all of that stuff. So we had a strong incentive to do security, and TLDR, it is difficult, as you might know, to get FedRAMP moderate. It's less difficult to get high, but it's burdensome in a lot of ways. And it's not to insult any regulation or anything else. It is what it is. And so a big part of it, I'll maybe sum up by saying this, like a lot of times you may encounter a sentiment among a product org that is like compliance is making us do. But it's actually, no, the business wants to, and compliance has the domain expertise to enable, so you are doing it to yourself. So we kind of got to this journey where we understood it was a product goal. And I think in sort of our first few years, it was more about the compliance was leading it, and compliance was working with product, but it wasn't quite as evident. So what it eventually led to was the creation of an organization in product with a product manager, and a program around it that was to own the roadmap for regulatory expansion. And regulatory expansion is all of the certificates you need to access whatever regulated markets you want. And that's going to run from not just the US government, but global governments, Korea, maybe China, other places like that. So it's just sort of the whole, which certificates should we get? And rather, which certification should we get for which opportunities? And what do we have to do to the product to get there? And the reason that fell to me, one of the reasons I was excited to work on it was, a lot of these frameworks are not telling you to do anything other than like brush your teeth and tie your shoes properly. And so if you consider that as like the baseline of good security, so what we wanted to make sure was that like we just married these two concepts very tightly. Like if I was in charge of product security, then also being in charge of like which controls already exist, how do we optimally map the controls, and how do we make our roadmaps comprehend this, what I would call like a bucket of perceived risk from customers, and then our roadmap for actual risk that maybe we're doing decomposition on, saying, okay, we need to solve all of this. There's obviously an intersection there. So the goal was to have both of those organizations so that we could, to use the business terms, align it. And I would say it was a good idea. It worked pretty well, you know what I mean? And I think that model continues.
Very cool. So then on to the main course here. So what is product security, and how does it differ from other types of security like application security or network security, things like that?
Yeah, it's funny, man. When you mentioned the cloud security architect, the first thing we did, I was like, when I took that job, I was like, I don't even know what a cloud security architect is. I guess we're just going to find out. So anyways, yes, it's funny. Very recently, I have heard the term product security. So the reason we called it product security at Snowflake was actually, that's our org showing. We refactored our security organization. In the early days, we were all just in product. And what we needed to IPO was a whole corporate apparatus, including security. And so when we thought about like incentives and how do we influence best, we said, okay, there's going to be a security group focused on product and one focused on corporate. And so we called it product security. Before we did that, I called it cloud and application security. So I think that maybe sort of answers the question in some sense. We owned all up what you can think of as the infrastructure posture, including the way the code was written, the way the code was deployed, and later on in the way that the product was being used by the customers. So potentially abuse and things like that.
So yeah, people always talk about shifting left. This is sort of like seeing how early can you introduce security into the development cycle, the right. Design decisions, all that kind of stuff. Sorry?
Oh, sorry, go ahead.
Oh, no, please.
Okay, so what I was going to say is, yes, exactly. And then as the org grew, we acquired the other pieces. So you could say like it starts with architecture, then it has assurance, then you have threat detection, then you have incident response, then you have red team, and you have pen testing either off to the side or as part of assurance. And what we were trying to do as an org is, tightly link all of that so that each of those loops was tight in addition to sort of that regulatory expansion loop. Yeah.
Are there key components or principles that you use for the strategy?
Yes. And so there's maybe a couple of different ways to answer that, but for me, it's about risk. And one of the things I obsess about lots of things, but anyway, one's like, how do I know I'm doing a good job? You know what I mean? Like that is the main thing, because you can have lots of good ideas, but you know what I mean? It can be BS. Yeah. So we looked at a framework, and of course we're at a high level in this company, so it's not like other people haven't thought about this. So it's a lot of, hey, what does everyone else think about this? And then our view on, I'll try to give a concise answer. We were all fairly educated as a leadership team on quantitative risk, FAIR, and that type of risk decomposition. Most of that sort of like asset-oriented risk analysis is maybe what I would call that, is known in the industry. So we got together and just collaborated on how do we make that a little bit better. And then the little flavor we brought in was maybe just to have a clear definition of like, what is the mission of what we're defending, so that we can have a way to know whether our controls are in conflict with the fundamental missions of the business. So we essentially just had a model that, so we have a mission model, we have a threat actor model, we have assets, we have a set of high level risks about threat actors with credible motives who are targeting assets that harm our mission. And that was the way that we sort of generate the hierarchy of risks we should care about, and maybe more importantly, at least a basic litmus test of which risks you should not care about, because it is maybe not credible for that threat actor, or maybe that asset is not actually important to you, which for us was really important. And as I think maybe anyone in a leadership role would appreciate, lots of people have an opinion on this. And so you have to have a way to reason about why we're saying what we're saying, and then they have to have a way to respond. And so that was our way to sort of say, here's how we're credible. Here's the homework. Here's the analysis, and even here's the confidence interval. Yeah. And that was kind of our main approach. And from there, we just said, okay, great. How do we mitigate these risks? And those led to a lot of the project planning. Maybe mention one other thing, which is like assurance doesn't neatly fit in. Like we're not trying to figure out what is the risk of assurance necessarily, or like threat modeling or pen testing. That's kind of like, I don't want to call it KTLO because that does it a disservice, but it is something that is next to maybe risk prioritization. Like you need to always be doing this, and it is a program unto itself that has to be managed with its own goals and OKRs that for me are very developer experience centric. And how are we helping developers to go faster, and how are we helping the business to go faster versus the pure act of managing risk to the business.
Mm-hmm. So how do you integrate security into the product development lifecycle? Especially like fast-paced DevOps, agile startup. How do you keep that front and center? Because I know it's easily the first thing that goes out the door when you're trying to quote unquote move fast and break things.
Yeah. So I'll say the biggest thing is, it's hard to anticipate the effects of scale. And so a lot of the things we learned worked at certain scales and then did not work at larger scales. So one of the good things about Snowflake initially was, from a cultural perspective, security was baked in, maybe overly so. And so it was not really a question that everyone was going to get a review. In fact, when I joined, it was, hey, go talk to this person who was kind of the early founding person. And so when I joined, I became that person, right? It's just like, okay, we're not going to release a major feature without talking to Jacob. That was kind of like how it went. And no one was going to break that sacred thing. And so that put us in a good opportunity to sort of say like, hey, that's not going to scale, but we're going to have to figure it out, because we won't know how to scale it unless we do maybe 100 of these, or you know what I mean? And so we kind of did that experiment. It was me and one other person, and we figured out, okay, here's how we can try to democratize and scale it for the first generation. And it was really just about like, hey, we're going to teach them the threat model. We're going to have the main thing we said was, we're going to do this champion volunteer thing. Like we're going to try to appeal to their developer senses. We're going to find the senior developer in the team, and we're going to say to that person, hey, you know how you peer review those people's code to make sure it's good? Like we're going to try to teach you the least you need to know to peer review the security that they're going to do. Like you're not going to do it. That's the main thing. Like you've heard of security champions, and maybe it doesn't sound good to you because it sounds like a lot of extra work. I'm not like, that was not our pitch. It was like, you're going to peer review. And then we taught each developer, how do you risk assess it? How do you know from the risk assessment if you need to threat model it? And it wasn't like we just took stuff from the industry, Go SDL and so on and so forth. So that was sort of the first generation, and we got better and better at that. But because Snowflake grew really quickly, then you live like 1,000 lives and die 1,000 deaths. Yeah. So sort of one of the other really important arcs that, like everyone talks endlessly about scaling AppSec programs. What I'll say is like your fate is somewhat in your control, but it is also tightly coupled with engineering. And so if as an engineering org, developer experience is not a priority, it becomes it's a different game to play where you may not be able to, there may not be, for example, in our early days, we had a very heterogeneous development platform, not just in languages, but in CI and code management, lots of different stuff. And if as a security organization, you're coming in and saying, reduce, because you really don't need all these things and everyone knew it, but who's going to be the bad guy then?
Yeah.
So that's kind of one way. Then the other way is you would say, well, we're positioned inside this organization, thank God, because now we can go to the other leaders and say, guys, isn't this of mutual interest for other organizations? So that was the main strategy we took, which was to say hey, we got to reduce choice, we got to do these things. So we took this two-pronged approach because at a certain scale, everyone knows that I'll say this, we had a very design-focused security, right? We were in front of each developer, actually making sure every change was getting some level of whatever we could expect from a developer. But as that scales, your ability to enforce consistency degrades quickly because that's a lot of knowledge and it works on smaller teams, but not so much over lots of teams across the whole world. You need to be able to deliver secure defaults. And that's the very obvious thing. But what I think is not obvious to a lot of people is you are not always in a position in a security org to just materialize them, right? Do you have credible developers who are ready to ship hot path services and code into production? I don't think a lot of security teams have that. I think some of the best ones at Google and other places do. But I think overcoming some of these barriers became a challenge and something we really focused on as we scaled because we saw that design-focused security has hugely diminishing returns and kind of turns into this curse for developers. You really have to focus on reducing the amount of effort. And so we got, I would say maybe the state of the art and the best that you can get for a developer to threat model their own stuff. But what we needed to get to quickly and where the teams were focused and have delivered is to obviate that. We have to give them more stuff that just doesn't require any thought at all and they can just use it, which tons of people have talked about. But I guess I'll say one last thing. In my journey, like many things, people talk about secure defaults. They don't ever talk about how they got there. And so I think to me, it was really hard for us to figure out how to deliver that. And because of where I was, it involved let's hire software engineers and let's go on this journey and convince leadership that we should do this. So I think that's something I would love to maybe learn more from other people. And I think other people should learn from each other because I think if you're working at scale, you're going to need to get here quickly. And if you're not working at scale, I think there's a lot you can do with design security, design-focused security that people are not doing.
Did you have any kind of internal education programs for developers? I know even software, I have a CS degree and my exposure to security was very minimal in university. It was all sort of on-the-job training kind of thing. Yeah,
we did. So we had, of course, the good old quarterly security training that really I would say kind of out of scope for this conversation, but I don't want to not mention it. And then we had focused developer threat modeling training, how do you risk assess, how do you think about these things? And the same thing for the security partners, a variant of that. And then we would even do team-specific ones, for example, the SQL team. Here's a bespoke one that sort of highlights how to apply these techniques to problems in your areas. And, most things at a company this big, you have an LMS or a learning management system, and this is all reported, so it's, it's mandatory. I think the thing that we did was focused on onboarding, and I think where we started to learn later was okay, you got seems obvious, but continuous education, and then which means you really have to focus more resources in keeping the content fresh and relevant. So maybe one big learning there is you have to invest in a lot of areas. You have to really invest in security champions or partners. If you do, you have to put people there who wake up and go to sleep and probably think about nothing but that if you really want them to be successful. And I found similarly with presenting learning content to developers, if you really want to be good at that, you have to focus a lot of resources on that.
It's not a simple problem to solve.
Not at all. Not at all. I mean, unless you're happy with the status quo of developers, people 2x the thing and don't pay attention to it and have no retention, which is the vast majority of corporate training people take, you know what I mean? But
sure.
We tried to be better. And what I'll say is it's always harder to be better as there's more people. You won't predict how much better you need to be to keep up with the number of people that are going to show up.
yeah, there's the sort of team spirit starts to get diluted as the company grows bigger, right? It's
yeah, I mean, yeah, and I think some companies weaponize it, like Amazon, and I think it's a growth every company goes through, right? You know, They have to figure it out, but they become more like islands, and then you have to think more about how do I make it relevant to you, because I don't want to say few things, but less things are generally relevant. You have to make it really, that person's day-to-day gets increasingly focused and specialized, which means that your advice has to get increasingly focused or specialized, because otherwise they just resent the fact that what you're telling them is not relevant to the things that they do each day.
Right. Are there common security challenges or vulnerabilities that showed up in the product development, like things that I'd say like to watch out for people who are maybe starting to think about this stuff?
Yeah, so I think about this a lot. So of course, CVEs in a regulated environment, those are hard. So I don't think that's really what you're asking anyway, but I want to acknowledge that like the amount of time and energy we put into keeping CVEs patched, even ones that were not exploitable, was tremendous because of the regulatory burden. But what was interesting about Snowflake was it's a database. So like, where's the database top 10? Like that doesn't exist. And if you don't implement like web routes, which we don't, we implemented SQL, it's kind of like, oh, well, what are the best practices for that? And the answer is only the people who wrote those stacks really know what the best practices are. And so you're really trying to, and I open anyone to debate me on this because I try to be self-critical and think like, is Snowflake really that special? Like, were the things we built here really, like, you know what I mean?
I mean, the name is Snowflake, right?
Yes. But at the same time, I felt like, look, how many people are building these databases? And like, go read 100 AppSec articles and tell me which one focuses on securing a cloud data platform. It's like negative 100 of them.
Yes.
So anyways, we just took, I guess, like a first principles approach. So the common things, I don't want to say common, that's tough. Where we focused heavily was when we, for example, we introduced code exec as a service. So in most databases, you have a concept of a user-defined function. And that is like a set of SQL that might run when you call one SQL, you probably know. So you can extend that, and some will support something like JavaScript, which we had for a long time, and then we wanted to extend into arbitrary languages, Java, Python, and other things. So it's like, great, now we have to, so it's not a common problem, to be totally transparent with you, but like that was problem number one.
Letting code execute in your environment.
Right, and to shift the architecture and to have the set of tools, like mental tools, some of them I described earlier, like how do you even think about this? Because, and this is where it really distilled this mission-oriented design analysis for me. It's like, one of the things is like, do we do Firecracker VMs? Do we do some other kind of VM? Do we do containers? Do we do something else? And the answer actually is quite simple because the startup time requirement was less than the VM startup time state of the art at that point. So it's like, great, VMs are off the table unless, disaster happens on one of these other paths and we just can't figure out how to secure it. And so just sort of going through this journey where they showed up and were like, here's a revenue projection. And I'm like, okay, let's have all of this stuff. And we found it really difficult to say how much risk were we really going to mitigate, and then some of the costs of the stuff was like more than the revenue we were going to generate. So that really forced us to like get serious. It's like, okay, it's not, we have to. Sure, we can tell them no. We could have done it at any time, every single day. But the whole point was to not do that, and so incredibly engaged with that. So I guess permission systems, anyone who has to implement permissions, that's a big part of any database. It's like how you assign permissions to various things. And of course, one of the difficulties there, and you see this show up in IAM, I think is like once you start to, probably use the wrong industry term, but like once you have enough stuff that you can be granted access to, like it becomes hard to minimize that access like out of the box. Like you just say, okay, Mr. Administrator, do a good job of that. But the database is really complicated. And so, those kinds of things would show up. And then, of course, internally we have, internal statements that are granted for debugging and other things. And so something we focused a lot on, for example, for SOCs, was to say like, okay, who has access to the metadata that, for example, because we produced our numbers from data in Snowflake. And so we had to have lineage from where the data was loaded and who touched it and did anybody modify it and all this stuff. And even down to from the debug interfaces in the product, because we stored the data in the product, like who can touch what we call, well, it doesn't matter the name, the metadata objects. And so the permissions of the statements which could access metadata objects, and then, for example, RBAC on that, to be able to say, like, look, you might say, oh, a general class of people can access debug functions. Anyway, it doesn't scale. Like, you eventually end up inventing subdivisions of that so that you can say, okay, some metadata is more special than other metadata. All customer data is special. So that's kind of the same, but your internal data maybe becomes a more interesting problem. And like for example, something I think Okta experienced, and we did not laugh or feel good at all about Okta's misery, because anyone who supports a customer and gets data about like a web-based thingy, you know what I mean? Like, we have a driver that is essentially using HTTP interface. And so we're collecting those debug logs and getting them sent to us too. And so thinking about that's like toxic. How do you treat that? How do you make sure that data is secure? And then of course the information you need to debug the product is often toxic in a lot of ways. And you need to make sure that that's being managed correctly and masked or access restricted and those things. So I think those are definitely common problems that, it's, again, to go back to something I said earlier, you have to be intentional. Like, it's not going to solve itself. Like, it will only get worse. And this is another one of these things I think a lot of people experience in rapid growth situations. It's like, one day it was a thing you knew that it's like, hey, we should work on that. And then, it seems like a day went by and it's like, okay, no, we really have to focus on this because it's like it's potentially a huge issue now.
Sure.
Yeah.
And I think you kind of mentioned it in that where you said we chose this one technology over the VMs because of the boot time. Is there other examples where like user experience and the security butt up against each other, and how do you make those decisions on which path to take?
So it's funny because something that was hard for me to understand was that Snowflake is one of its market positions is about being very easy to use. And like as a person who did not come from the database industry, I came from FreeBSD kernel programming at Citrix. I was like, what are you talking about? It's very difficult to use. But you know what I mean? But I guess relative to the industry, it's quite simple to use. So when we thought about like security friction, a lot of it was to think about it from the internal perspective, because I guess one of the double-edged parts of the product security sword is that there is often an industry term for product security that focuses on the security features in the product, like who wrote the SSO integration, who writes the password policy thing, who writes those other things, and that it was not our team. But of course, that doesn't mean you can work separately in a silo. So what I'll say is our largest concern was how do the controls we introduce either reduce or increase developer friction. And then toward the later end of things, when Snowflake launched Marketplace, we said, we can't really take this infrastructure-only view of the world. Like, we now have to assume that bad actors will target each other on our platform. It's no longer just a single tenant type of risk. And so abuse has to become a concept. And so we started to look at that and build those teams out as Marketplace became a thing in Snowflake.
You're talking about all the teams in this company as it scales and not being in a silo. Is there things that, like, how do you make security a shared responsibility across the different teams instead of just having people throw it over the fence and say, well, that's not my job?
Yeah. For me, and I hesitate to say any advice works for everybody, but if you don't have the definition of relationship, like if you're not spending a lot of time, or your boss or someone, like, you need to know that someone spends a lot of time with the top level of engineering leadership. Like, if that's not happening, I feel like it is very difficult to get anything done, because you're fundamentally fighting misaligned incentives. You're asking someone to do what their boss is not asking them to do. The game is to make their boss ask them to do it. And there's 1,000 ways to put leadership, put stats in front of them and have them compete and do all that stuff. But like, that's where it is. If you lack the ability to influence leadership that can make the decisions for the organizations you're trying to govern, it's big problems. And so that's where I spent my time. And fortunately for me, that's where I reported, was in the engineering leadership team. And so those were, at some level, my peers. And so I would just have a conversation both as a group and individually to say, like, guys, don't we need to do this? And it wasn't like, don't we need to do this? Like, everybody knew we needed to do it. It was about, how do we make it work best? Or, hey, we have to make, I think a big conversation we had a lot was, how do we get strategic priorities that take away from product priority resources? How do we know which are the most strategic risks that we have to make big investments in when we have to iterate the platform or do things like that to sort of keep up. So we just spent a lot of time understanding that and having those conversations.
So like collaboration and shared.
It maybe sounds corny and cliche, but what I'll say is security is I don't know. Sometimes I get criticized for my metaphors, but it's like a psychological operations game, and like you can approach that with good or bad intent. I highly suggest you do it with good intent. But like if you're not engaged in the psychology and influence, then you're not doing security. Like you're probably feeling very frustrated and that you can't get anything done. At least that was my observation. Extremely important to have relationships, and if I could pick technology or relationships, and it might make people cringe. I consider myself an engineer, but like. You got to have relationships. Like you cannot just show up with the technology. It won't succeed. You'll quit because you'll say none of my work gets delivered.
Yeah. Were there specific KPIs or metrics you used to measure the success of the programs you were building? It seems like security oftentimes it's hard to show value, especially when it's working really well because nothing bad has happened, right?
So I guess it was both a strength and a weakness. At like a very team level, I'll say I was never good at like how do I measure the factory output, dwell time, cycle time, all of those things. What we tried to do instead was one, empower my managers to think about that as I sort of moved up and just looked at this as my weakness. It is what it is. But what we then tried to focus on was risk reduction. Like, okay, how can we do a meaningful analysis that says we move the needle on a risk? And I sort of described the approach we took to do that. The second thing we would do is look at the ability to preserve regulated business. So like did we, it may sound funny to talk about it this way, but like there's a risk of losing regulated business if you don't patch. And you could actually choose to do that, you know what I mean? And so one of our success metrics was like, okay, great, are we within SLA on everything we need to do to maintain our certificates? And of course, that sounds very like boring and maybe checkboxy, but like if a huge part of your business is maintaining it that way, then you have to think about the revenue generation portion of what you do or revenue maintenance portion of what you do, in addition to the risk reduction. So when we thought about rolling this up to the board, we took them, I won't say quasi-quantitative, but like all quantitative methods have some error bars, have a confidence interval. That's how we rolled it up. We would say, okay, we've decomposed these major risks. Here's the progress we're making quarter over quarter. And we can look at, we said these controls would mitigate this much risk. Now, do you ever get to find out, did that control really mitigate the risk? Not, it's like you said, maybe you do, maybe you don't. But you do the homework and say, this is what needs to get done. And then we essentially reported the log on, is it done? And the way we felt was more meaningful to frame that is how much of the risk is remaining. Because we may make a choice that actually, okay, it's good. Like it doesn't, if you can boil it down to a set of dollars, which we often did, is to say like, okay, how much risk are we going to accept? And maybe I'll just say one thing about that is a lot of risk acceptance happens without criteria, right? So people, you know, as you talk to your industry peers and other folks, you're going to hear lots of accepted risk. And I think the key question is like, how do you know how much is too much or too little? And so that was something we tried to focus on. But admittedly, pretty high level. Now, of course, we looked at sort of a click down of metrics in terms of like I said, vol and SLA performance, number of sort of like access patterns, number of access and how frequently it's being accessed so that we could see overall trends. It's not necessarily measuring the team, but it's measuring the risk posture of the business by looking at parameters. I don't want to say parameters, but things like how many vols are in and out of SLA, how many missing assets, who has access, how often do they use it, what is the trend of that access over time, and maybe the whole CIS sort of corpus was decomposed into a set of dashboards that we use to measure the program.
Very cool. Do you have any advice for companies that are just starting to build their product security programs? Like, what's a good set of things for them to really take in and think about before they start moving pieces around?
Yeah, so I'll say a couple things. It's got to be the right thing for the right time. And so this really scaled, developer-driven thing is maybe not the first thing you should do. I think like the first thing you should do is probably very hands-on, because I feel like you have to learn how to build the scale by getting your hands dirty. So I think maybe the key thing is to establish the relationship with engineering leadership before you do anything else, because otherwise you're operating in a black box. So I really think like if you're starting a security team, if you're joining a company as even a senior security engineer, senior architect, whatever you want to call that, that's something you should be asking, is what is the relationship between you, whoever you are, maybe the hiring manager and engineering leadership, and how do we work with them? And I think really ask some real questions and have them explain to you how it happens on a daily or weekly basis. And if you don't hear a daily or weekly basis, I would say that's a big red flag. That's going to be friction and work on you to try to build relationships that don't yet exist. So I guess for very early teams or people who have not even joined, that's the advice I would give. The other thing is then to, of course, just be engaged with the developers. I think over the arc of my time at Snowflake, I come to regret, I don't want to say regret, I don't regret anything, but like dislike some of the decisions we made because I'm kind of a relentless pursuit of better person. Mm-hmm. So naturally, I think after 2 years, you need to really be aggressive on probably everything needs to be reevaluated every 2 years, especially if you're at a company that's scaling. So what do I want to say by that? I think it's important to sit with the developers. I think it's important not to take too hands-on, or rather too prescriptive of an approach. I think stride-based threat modeling is pretty tough, and I think I would rather not do that again. I think there were some things about how we converted that into structured data that were super valuable later, but like I think a lot of this like what could go wrong type of conversation and preserving artifacts. In other words, don't just do it on a whiteboard, but have a structured thing that is near the code, that is persistent. And I guess I just don't want to go on and on, but listen, I think the key thing we said was documents die. No one cares about what was on the whiteboard. No one reads what's in Confluence. What they care about is the code and to a lesser extent the tests. So it doesn't mean you can just wait and audit the code, but it means that what you produce needs to be very near the code, and it probably should be tests, because the output of most like low stakes security review are either a high stakes security review is change the design document. A low stakes security review is like, fix the code. So I think those are two very different things. Yeah.
Cool. Any specific resources or tools that you've encountered along your way that would be valuable for anybody, things that maybe are a little lesser known?
Yeah. So if you're into quantitative risk analysis, I'll say like you may have found it difficult to apply. You may have read the Measuring and Managing Information book from about FAIR and how to apply that, and I don't know, had some questions. So that was actually something when I think about threat modeling, I mostly think now about, not because developers are not important or something, but like how do security engineers know how to threat model good, maybe to use terrible language, but like I don't think that they do. And I think based on my experience in hiring a lot of them, each one has a different way that they do it. And that can be good. I don't necessarily think so. I think it makes it very difficult to understand, how do I know I did a good job?
Yeah.
Especially when the stakes were as high as what we did here. So I found there's a book by Ross, somebody called Security Engineering. Go ahead, read that, but I think that's fairly old text. I found a text that sort of married those concepts with a very practical application of quantitative risk analysis. And it's called Engineering Trustworthy Systems. And you can find that on Amazon. But anyway, I found that book super enlightening as a framework to just sort of think about, how do I think about threat actors? How do I think about motives? How do I think about the mission? Like the main thing from that, they had an epiphany and I read it. It's about, you really have to focus on the mission, and it gave me a framework to sort of, my journey is always sort of serendipitous for whatever reason, but like the universe told me the right things at the right time, and I was like, oh, this is how we can, bring this together with what they're telling me about this hugely risky remote code as a platform, and like how I can respond to that in a credible way. And it became a very credible way to have a conversation on many risky features thereafter. So I think that those are some great books. And I just maybe would say like this thing about how do I know I did a good job? You're going to encounter a lot of different personality types in security, and I can't tell you who to work with or who to hire, so I can only appeal to the individual. Like, don't be the type of individual that thinks that you know. Be self-critical and ask, like, how do I know? Like, what are best practices? Don't exist in a world where you are the single source of best practices. Like that, it's the old classic, don't be the smartest person in the room. If you're the smartest person in the room, you're probably wrong. A lot of people say you're in the wrong place, but I think it's probably like you're probably more wrong than the place is wrong. So.
Oh, that's great. And I do think, like we sort of have this engineering approach. I have this engineering approach to cybersecurity and in the way to think about scaling systems and stuff. But security definitely does suffer from everybody does it a different way. And I think if we're going to get there and solve the larger mission, we have to have a guidebook for how to build bridges, how to build towers. Like, there can be some variation and some creativity within those frameworks, but we don't need to reinvent things every time we build it, because that's how these problems show up?
I have kind of a spicy take that maybe sums my view on that. It is very difficult to teach security engineers to become software engineers. It is much easier to teach software engineers what they need to know about security. The thing is those come on a continuum of maturity. You're not ready to start with these software engineers who are not security experts in the very early days where you're sitting with other software engineers. But, it's not the early advice, but a key thing we really learned was you cannot be credible in software without credible software professionals. And don't do a disservice, one, to the security professional by overextending them and doing a disservice to the skills that they have. And two, don't do a disservice to the software engineer. By assuming that they're going to know everything or not, sort of having a security pair there, or those kinds of things. And one, that software engineering is a professional skill, and shipping in production is serious business for a SaaS product. And you can't, you have to be credible on one side or the other.
Yeah, I find that take really interesting. I've often said that I think the future of cybersecurity looks a lot more like software engineering than it does security today, and most of the talent will come from the software engineering side, I believe.
Yeah, I completely agree. I think the challenge could be, how do you attract? We had some interesting problems, and so we could get software engineers to come, and abuse was the main opportunity. It's develop the detection systems, develop everything after that, which is pretty cool. But I think people are gonna have to figure that out. They have to either partner or figure out how to attract that talent themselves. But either way, you're right. Software engineering is where scale and things like secure defaults come. And if you're not doing that, the other house of cards eventually sort of falls over.
Okay, so this is the last one I have for you. It's the one I ask of everybody that comes on the show. It can be as wide or as narrow as you want. Do you have any predictions for the future of cybersecurity?
Look, man, I think cybersecurity is like a bloodbath right now. You see what's happening in healthcare. You could say it as much as you want intellectually, oh yes, everyone's going to get hacked. But no, they really are, every day, all day, every day. So I sort of think there's a couple of things that are happening. I don't sort of think that they are. The SEC has attempted to set a regulation. We do not yet know what effect, if any, that will have. But it boils down to this: incentives are not aligned. And I'm not the first one to say this. Businesses do not suffer greatly as a result of security defects. They don't yet. And SEC enforcement, we don't know what that's going to look like. Is it actually going to create incentives? Is it just going to have this chilling effect on security professionals, as a lot of the discussion has been? So I think I don't know what's going to happen in the future. I think the future is about to be sort of telegraphed soon, and we need to be paying attention to what happens with regulation, because I sort of view this as I don't want to say unwinnable, because that's kind of cynical, but it's not ending. So either, and fundamentally, either consumers are going to get upset or protections are going to have to exist because lives are being harmed. I don't want to be a dramatist, but everyone probably knows now at this point, the Change Healthcare breach caused disruption in providing care. The CrowdStrike, not that it was a breach, but these,
it's an engineering fault.
Correct. And again, I'm not here to pick on CrowdStrike, but this technology matters. And I think as a society, we have denied the societal importance of this, and it is becoming impossible to ignore. And just knowing human systems and civilizations as I know it, it's probably going to lead to regulation. So regulation will, I think, define the either absence or presence of regulation will define what the future of cybersecurity looks like. And I don't yet know, but I know that the wheels are in motion, for some of them at least.
Very cool take. Awesome, man. Well, thank you so much for being on the show with me, Jacob. This has been a really great episode, and I'm excited to maybe talk to you in the future and see what you guys are doing when you finally launch your company.
Right on. I really appreciate it, man.
Okay, take care.
Cool. Bye.